Okay, so this is number 1 on the study session. So on number 1, there's a bowling ball, and it is rolling at a speed of 5 meters per second. Here's our ball, rolling at a speed of 5 meters per second along a horizontal ramp on a rooftop, which is 48 meters above the ground. So it's on a horizontal ramp going 5 meters per second. Since it's a horizontal ramp, what that indicates is that it's going to be released going in the x direction. So this is our velocity in the x. We also know that it is a distance of 48 meters above the ground. So our bowling ball is slightly out of scale, but that's okay. Alright, so this first question asks, where would it be a bad idea to be standing? So somewhere over here is where it's going to hit, and that would probably be a poor place to be standing. So if that's what it's asking, I'm probably looking for the distance in the x. Okay, so I'm going to be looking for the distance in the x. So let's solve for the distance in the x. So I'm going to come over here. Keep in mind the 48 meters and the 5 meters per second. Alright, so come over here. We've got a distance in the y of 48 meters and a velocity in the x of 5 meters per second. Okay, and we're trying to find dx. So if we're trying to find dx, there's only one formula we can use. Vx equals dx divided by t, and we need to find the time. So we've got to figure out a way to find the time. So we're going to use our go-to for finding time if we have the height, which is dy equals 1/2 ay t squared plus biyt. Alright, now since it was launched horizontally, the initial velocity in the y should equal 0. So this goes to 0, and I'm left with 48 equals 1/2 times -10 times t squared. Make that negative since it fell 48 meters. And if we solve for this, we should get t squared equals the square root, or sorry, t is equal to the square root of 48 divided by 5. Pretend that's a 5 down there. And if we do that, we get a time of 3.1 seconds. Okay, 3.1 seconds. So that means we're going to come back up here and we're going to plug it in to this formula. So we know 5 meters per second, and we know dx is unknown, and we know now the time is 3.09, or sorry, 3.1. So since it's 3.1, what we're going to do is multiply 3.1 up, and 5 times 3.1 is 15.5. So dx then equals 15.5. It would be a horrible idea to stand at 15.5 meters away from that building, because that is where the bowling ball is going to land. Second question, part B, says where is the bowling ball 2 seconds after leaving the ramp? Well, if we take a look at our ramp and bowling ball situation, the bowling ball is going to make a path something like this. We know from this problem here that it's going to take a total of 3.1 seconds to hit the bottom. So at 2 seconds, it's probably somewhere right here. Let's just say it's right there. Alright? Well, if we're trying to find this, all we've got to do is do a formula for dx and a formula for dy. Well, dx, we should know by now, the formula is vx equals dx over t. If we solve for dx, it's dx equals vx times t. So we got to do that formula. We also have to do 1/2 ay t squared plus biyt, because it's the only formula. We also know that the initial velocity in y is 0, so that goes away. Now, what time do I use? Well, since it tells me that it's 2 seconds after leaving the ramp, I'm going to use 2 seconds. So dx then equals the velocity in the x, which is 5, times 2. So in the x direction, it's at 10 meters. In the y direction, do the same thing. dy equals 1/2 times -10 times 2 squared plus 0, because it went away. So the distance in the y is, let's see, what would it be? 4 times 5, so it'd be -20 meters. Alright, so dy would be -20 meters. Now what that means is, at 2 seconds, our ball is 10 meters in the x direction away from the wall, and 20 meters in the y direction away from the start. Alright, that's where the ball is. So if we had to describe where it is, there you go. Alright, question 3. What is the vertical speed after 2 seconds? Well, the only thing we've got, if it says what is the vertical speed after 2 seconds, we're looking for a final velocity in the y. And we're looking for it after 2 seconds. The only formula we have with the final velocity in the y is this one. Acceleration in the y equals final velocity in y minus the initial velocity in y divided by t. We know the initial velocity in y is 0, so we cancel it out. So we're left with negative 10 equals final velocity in the y over 2, and negative 20 meters per second is equal to the final velocity in the y. There you go. That's C. Last one, D. What initial speed would the bowling ball need in order to hit a target 15 meters away? Well, in this case, what we're saying is, what if it wasn't going 5 meters per second? What if instead it was going some other speed? So, we know that we've got the same setup, everything else is the same, still 48 meters tall, still rolling the bowling ball off at some Vx, and we know that the distance in the x is equal to 15 meters exactly. So, what that means then is that we need to solve for the exact velocity in the x. Alright, now, the time should stay the same. So t should still equal 3.1 seconds because nothing changed except the velocity in the x. The height is still 48 meters on this one and on this one. So since the height is 48 meters, it's still going to take only 3.1 seconds to fall. So we do Vx equals 15 divided by 3.1, and 15 divided by 3.1 is 4.84 meters per second. Alrighty, so there you go. That's number 1. Okay, so hopefully you all understand how to do it, and you will do wonderfully on your test.